Don't move. Direction angle is measured from the positive side of the x-axis. Okay, so what it looks like. Okay, let's say the component form of your vector is over here in quadrant 2. So that's our vector. The angle measured from the positive side of the x-axis to the vector. So this angle right here is called the direction angle.
It's about 115.
Oh, is that what you think? Okay. At the top, if u is a unit vector, therefore fitting on the unit circle, correct? Because the unit circle is the radius is a unit. The theta is its direction angle. The terminal point of the u lies on the unit circle and, okay? Component form is going to be cosine theta sine theta as a vector, okay? Where else do we have pairs of numbers that are cosine theta, sine theta? On the unit circle. Very good, okay? Linear combination form is with I and j. So it's cosine theta I plus sine theta j. That's not going to be any big deal because when I do direction angles, I always do them in component form.
You don't need
Okay.
the brackets around,
The front, no, around linear combination form?
yeah.
No. Okay, never brackets around linear combination form. Okay. All right, we're going to go down to example 6 because that's the first one that they ask us to find the direction angle. These are going to be so easy, guys. First step is to write the vector not in linear combination form, but to write it in component form. Anybody know, raise please, what the vector would be in component form? Right now it's linear combination. Autumn, go ahead.
Is it just negative 4 and 5?
Yes. Okay. Next step is to graph. As if you were graphing a point or a vector on the unit circle. Okay? So the vector negative 4, 5 is negative 4 to the left and 5 up. Okay? The direction angle is right there. Okay. We're going to do what we've done in the past. We're going to drop an altitude to the x-axis. This was negative 4. This component of the vector was 5. Okay. Now I'm going to ask you guys, how can we find the reference angle? Remember, the reference angle is the one inside the triangle. Anybody know how, raise please, how to find the reference angle? Go ahead, Miss Leah.
Would it be, because it's opposite over adjacent, so would it be a tan inverse?
Yes.
Negative 4, 5?
You are exactly right. And that is actually stated right here.
Is it always going to be tangent though?
Yes, it's always going to be tangent. Yep. And this is going to give you the reference angle. So yes, it's always going to be tangent. Now another way that they define it as tangent theta equals b over a. That's when the vector is written in ai plus bj form. The direction angle will always be the tangent of the the vertical component divided by the horizontal component. It's always vertical component divided by horizontal component. So what we want to punch in our calculators is tan theta.
Oh, it's not inverse?
Well, yeah, it will be. 5 over negative 4. And then I always ask you the question, what button on your calculator will give you the theta? And tan inverse is what Leah was saying. So we're going to type in tan inverse 5 over negative 4. Okay, so what'd you get, Max? Okay, so Max got, I have negative 51, negative 51.3. Now, here's the issue, guys.
Oh, I know what happened.
Wait, the issue is, if you're in the unit circle, negative 51.3 is down there, okay? We want our direction angle to be over in this quadrant. So the easiest way to get it over into quadrant 2 as opposed to quadrant 4 is using reflections from geometry. So I'm going to take the negative 51.3, I'm going to reflect it into quadrant 1. And then I'm going to reflect it over into quadrant 4. So this angle right here is 51.3. Now, they don't want the reference angle, guys. They want the red angle. Okay? So somebody tell us what math we would have to do to find the red angle. You always want the red angle from the positive side of the x-axis. Go ahead, Brianna.
180 minus 1.
Very good. Okay, so what we want to do is we want to do 180 minus 51.3. Okay, so 180 minus 51.3. What do you get, Brianna, when you do that?
128.7.
Yes, so you get 128.7, and that is our final answer.
How can you just reflect it like that?
You can't, as long as you end up in the right quadrant. The way to get to the right quadrant is to reflect as many times as you want it. I could have reflected into quadrant 3 and then reflected into quadrant 2, and that would have been fine too. You would have ended up with this angle being 51.3. But I would reflect. I would reflect to get into the quadrant that I need to get into. Okay? All right, the other thing in this section is up above, right here. This is how you find what's called the velocity vector.
Sounds like Jason.
Vector. Velocity vector. Okay, sorry you can't see that. Okay. Velocity vector, they're going to give you a word problem. So that's when we'll use velocity vector, okay? The velocity vector is defined as the ordered pair. Actually, I don't like either way that they have it written. It's the component form, and it's the magnitude of the vector times cosine of the direction angle, comma, magnitude of the vector times sine of the direction angle. And if you remember yesterday, the guy in the video did those at the end. So this is your velocity vector. All they did up above here is they wrote it in linear combination form instead of component form. Okay, so we're gonna do a word problem with velocity vector right now. Yep. We're going to use the white space underneath application problems. I'm going to put the word problem over on the left, and then we're going to do another just direction angle question over on the right. So word on the left, direction angle question on the right. Okay, everybody good? All right, so what we're going to do is we're going to do a word problem. And then we're going to leave a little room over here to do another example of a direction angle. Okay? Here's our word problem. The wind is blowing 20 miles per hour. Now, a speed can actually be a magnitude. So what they just gave you is the magnitude of the vector. A speed can be a magnitude. In the direction of north 30 west, find the component form of the velocity vector. All right. The first part of the velocity vector is the magnitude of the vector. Well, the magnitude of this vector is the speed. So do we know the speed? 20 cosine theta 20 sine theta. Okay, now we just have to find theta. Now remember, the direction angle has to be the red one that I draw in here, from the x-axis over to the vector. Well, that should be pretty easy for us to find. We know here to here is 90. We know this is 30, so the direction angle is? There you go. Okay, so it's going to be 20 cosine 120, 20 sine 120. Now, ooh, bad. Now, this is where we need is 120 on the unit circle. So now from our unit circle, we found cosine 120, sine of 120. Well, 20 times negative a half, gang. Negative 10. Now, this 20 times root 3 over 2, I would put 20 over 1. Is there anything we can cancel diagonally? 2 into 20 goes 10. And then we can just write 10 root 3. Now, depending on the problem, usually if it's a number you can pluck off your unit circle, then you write the answer like this. Can the answers be written as decimals? Yes, they can. They can also be written as decimals. So will you get numbers on the unit circle always? No. Okay. If this is something not on the unit circle, just use your calculator and punch in 20 cosine 120, and you can give me a decimal value here, and 20 sine 120 and give me a decimal value here. But if the number is on the unit circle, we do prefer that you use the unit circle. Does that make sense, guys?